My dear friends, welcome back to Be Spice. In this session, we'll discuss about SCADA system, supervisory control and data acquisition system. Okay, so in part one, what we will focus, we'll focus on intro part. Okay, then we'll talk about SCADA network. Okay, how the data is collected, all this. Then we touch upon a bit on architecture as a general. Then we will dive deep into the hardware architecture. Okay, then we will also talk about the software architecture. So in part one, we'll be focusing on these five aspects. Of course, there are many more, items in this, SCADA aspects, like, the functionalities, the components, the typical application, advantages, and of course, the comparison between, SCADA and PLC. All these we are going to cover in the subsequent session. So this is the part one. Okay, friends. Yeah. So before going into the detail, once again, thanks a lot for all your support. Keep supporting and keep watching. Okay, friends. So intro, as we discussed in the beginning, SCADA stands for Supervisory Control and Data Acquisition. Okay. So it's simple, right? Yes. So basically, it's a type of software application program for process control. Okay. As simple as that. So SCADA is a central control system, central control system that consists of controllers, network interfaces, input output cards, communication equipment, and software. So it's a combination of controllers, network interface devices, input and output modules, communication modules, and software. Right, friends? Okay. So SCADA systems are used to monitor and control the equipment in the industrial process, which includes, manufacturing, production, development, fabrication, all. Okay. So the infrastructural processes include, gas, oil and gas distribution, electrical power, water distribution, and also the public utilities, including the bus traffic system, in fact, MRT, the train system, airport systems, all these, it's fine use. Okay. So the SCADA system takes the reading of the meter and check the status of sensors in regular intervals so that it requires minimal interference of humans. So this is just an intro part, friends. It's what you call self-explanatory. I hope is clear. So no need to further deliberate on this. Okay, right. So now we'll go into the what you call network. Okay, friends, just listen to this. You have one pump here, right, friends? And the pump control, okay? And you have one level control, right, friends? Okay. So basically, this SCADA system reads the measured flow and level. You know, here, this is your flow and this is your level, okay? So it reads the measured flow and level and sends the set point to the PLCs. Set point to the PLCs, okay? Sensors and send the set point to the PLC. Okay, so if you see here, this PLC1, this gentleman, compares the measured flow, right, to the set point set by sent to the PLC by the SCADA system. Okay, and controls the pump speed as required to match the flow to the set point. And if you look at it here, the PLC to this gentleman compares the measured level to the set point and controls the flow through the valve here, right? Flow through the valve, okay, to match the level to set point. So this is just a, simple, representation, friends, how this, SCADA is, working, okay? So this is the one, of course, we are going to go into the details also, but this is just an overview, right, friends? So this is about the SCADA network. Then we talk about the architecture. Generally, SCADA system is a centralized system, that monitors and controls the entire area. That is one of the versatility of the SCADA system. It's distributed geographically at further distance, even 200 kilometers, you can get the data. Okay. I will explain that in the subsequent session. No mind. Okay. So it's basically a software package that is positioned on top of the hardware, right? So your supervisory system gathers data on the process and sends a command control to the process, right? So the SCADA is a remote terminal unit, which is also known as a RTU. So RTU based, right, friends? So most of the control actions are automatically performed by the RTUs. So the RTUs consist of a PLC, which can be set to specific requirement. For example, in a thermal power plant, the water flow can be set to a specific value or it can be changed according to the requirement. This is just an example. Okay. So this is all about the architecture. Okay. Right. Now we go into the further details actually. The SCADA system, friends, allows the operator to change the set point for the flow and enable alarm conditions in case of loss of flow or any other things, high temperature or pressure, whatever is that. Okay. So using the SCADA, he can do it. That is the point. The SCADA system monitors the overall performance of the loop. Okay. So the SCADA is a centralized system as we discussed earlier. It communicates both wired and wireless also to the client devices. So that is also options are there. The SCADA system controls can run completely on all kind of industrial process. So these are the some of the items which I want to highlight as part of architecture. For example, in this case, if too much pressure is building up in a gas pipeline, the SCADA system can automatically open a valve release. This is just an example. Okay. Yeah. So now I go into the hardware. Okay. Just look at this picture, friends. You have these PLCs, right? So you have a SCADA with a database, and you have this serial to Ethernet, all these, converters are there, and it is all connected to the LAN. And yeah, you have your programming from any location. It's like an engineering station or your laptop. Okay. So this is a typical hardware involved in this. And of course, we are going to talk about the components level individually later. Okay. So again, this is an overview, friends. Generally, SCADA system, is classified into two parts. You are aware, right? One is a client layer, other is a data server layer, right, friends? So the client layer caters the man-machine interaction. That is the HMI or MMI. Okay, where the operator sits and monitors and do the operations, right? Yes. So the data server layer handles most of the processor of the data activities. Most of the process of data activities. That's it. Very simple. Okay, hardware part, client layer and data server layer. That's it. Client layer, man-machine interaction. Data server handles the data. That's it. Now, few more to add on. The SCADA station refers to the server and it is composed of a single PC. Right, friends? Okay. So the data server communicate with the devices in the field through process controllers like PLCs or RTUs. Can you able to visualize? See, SCADA system refers to a server and it is composed of a single PC, right? So the data server communicate with the devices in the field, all our field transmitter. Of course, I have not put in here. So that will communicate in the field through process controllers like, PLC. So here devices are there. So it will the data server will communicate to the devices through the process controllers like PLC or RT. Okay, friends. I hope this is clear, right? Okay. The PLCs are connected to the data server either directly or via network or bus. That's what this guy, right? This PLC are connected to the data server either directly or via network or bus. Okay. So the SCADA system utilizes the WAN or LAN networks. Okay. So this is a WAN and this is a LAN. Okay. Right. So the WAN and LAN consist of a internet protocol used for communication between master station and devices. So that is the purpose of this. Okay. So clear, right? Yes. Now, few more to add on. The physical equipment like sensors connected to the PLCs or RTUs. We already discussed, right? Yes. So the RTU, what this RTU convert the sensor digit signal to digital data and sends to the master. So that is what this RTU is doing. Okay, right. Most of the monitoring and control operations are performed by this RTU. Okay, right. So that's it, friends. Right? Okay, good. That is about the architecture. Now we will dive deep into the software. See, software, this is, you can see here, friends, this is a look and feel. You see here, here you have your, PLC, all this, it is communicated through OPC, and you have the database here, and, it can be a sequential server, SQL server, RT, a database, alarm database, long database, RQ database, all these are here, right? Yes. So this is your SCADA server, client server, publish, subscribe, based on the TCP/IP protocol, your HMI, trending, alarm display, log display, all these are here, right? So this is what, inside we are talking about software. So many things are part of this, okay. So most of the server are used for multitasking and real-time database. That's right, yes. So the server are responsible for data gathering and handling. This we all know, right? So this is about the software and few more to add on. The SCADA system consists of a software program to provide trending, which I highlighted earlier, trending, diagnostic data, okay, manage information such as scheduled maintenance, procedures, logistic information, detailed schematics for a particular sensor or machine, and of course the troubleshooting guides. All these features are available. Okay, friends? Right. So this means the operator can see the schematic representation of the plan being controlled, right? Yes, that is about the software. So we are done with this, the intro part, friends, SCADA part one. Now we will talk about part two, which will focus on the, how the SCADA exactly works, how the data is gathered, and what are the components inside, and of course the applications and advantages. All these we will see in the part two. Okay, take care. Thank you for your support. Bye bye.